establishing contact, accessing data, accessing archives, archive found. Hello. My name is SCA001. I am an AI responsible for Simple Chemistry Archives. Or, you may simply call me the Alchemist. This archives contains the information about various chemistry topics that we will try our best to explain as simple as possible. Please keep in mind, this particular video is very simplified. So all the topic that require more explanations will be covered on separate videos. The earliest definition that the world is made of very tiny particles is very old and goes back to ancient cultures, such as Greece. The word atom itself is a Greek word which means unable to be cut. Democritus was the first to comment on the structure of atom. He theorized that the atoms have mass and volume. He also believed that the properties of matter come from the shape of their founding atom. For example, sour-tasting things have rhombus form, or water has round atoms. Although Democritus had the basic concept correct, but the real theory about the atom and its property was devised by Sir John Dalton. He expressed his theory as this. 1. Elements are made of extremely small particles called atoms. 2. Atoms of an element are identical in size, mass, and other properties. Atoms of different elements vary in size, mass, and other properties. 3. Atoms cannot be subdivided, created or destroyed. 4. Atoms of different elements combine in simple whole number ratios to form chemical compounds. 5. In chemical reactions, atoms are combined, separated, or rearranged. Dalton's theory was accepted at its time and did answer all the existing questions. It remained unchallenged for almost a century until the discovery of cathode ray phenomenon. Cathode ray tube, or simply CRT, was a device comprised of one vacuum tube with two metal nodes in each side of it. By applying an electric potential to both nodes, electric current would move through wires to the node and start to build up there and then discharge. This discharge would create an unknown bright beam. This concept might be familiar for us now, but it was an unknown phenomenon at that time. Many theories were devised about it, but lastly, Joseph J. Thomson took an interest in this device and performed some interesting experiments to discover its properties. At first, he changed the nodes into different metal, but the result was same and the beam kept coming. He assumed that all the metal must have this thing inside them. Then, he put a small object on the path of that beam and it made a shadow. He noticed that the beam travels in straight direction. He put a magnet near the beam and noticed that the bright beam separates from its path. The same thing happened when he put the beam inside an electric field. So he assumed that this cathode ray has both magnetic and electric properties. In addition, putting a small pinwheel on the path of this beam made the pinwheel spin. This showed that this beam has mass and made of some particles. After these observations, Joseph J. Thomson came up with his theory. He had discovered a new particle. He named it corpuscle. This new particle was 1800 times less mass than a single hydrogen atom. So this new particle was not an atom, but a new subatomic particle. Later its name was changed into electron. Thomson then came up with his famous atomic structure. Atom was a sphere with positive charge, and the negatively charged electrons are distributed throughout the atom in a sea of positive charge. Similar to seeds in a watermelon or plums in a plum pudding. The discovery of electron changed everything. Thomson's model, although was revolutionary, but had some flaws. For example, he associated the mass of atom only with electrons. Thomson's theory was rejected by Hinataro Nagaoka, a Japanese physicist. Nagaoka proposed a new model for atom, in which he predicted that the electrons must be revolving around the center of atom, and the center must be very massive. His Saturnian model was implying that, similar to the planet Saturn and its rings, the electrons are revolving in a ring around a dense and massive atomic center. His model seemed more rational than previous models, but it was to be proven by Rutherford later.
And on this occasion, I wish to say a few words on the methods and ideas employed to break up atoms and to realize.
At that time, Ernest Rutherford knew that radiation coming from radioactive materials were made of three different forms of beams. Alpha rays, that has positive charge. Beta rays, that has negative charge. And gamma rays, that was neutral in charge. Rutherford designed an experiment to test Thomson's theory. He put a very thin layer of gold in front of a single beam of heavy and energetic alpha rays. He assumed that, if what Thomson said is true, an atom is mostly empty space, then alpha beams will go through atoms without any problem. He conducted his experiment and noticed that a big portion of alpha rays passed through gold layer, as predicted, but to his amazement, he noticed a small portion of the rays got bent and some even got deflected. This raised the question, why? A big portion of the beam has passed because most of the atom was considered empty by previous model, but Thomson's theory could not explain why some beams got bent and some even got deflected. So Rutherford came up with a new model. He assumed that a big part of the atom is empty space as Thomson said, but instead of scattered positive charge, all of the positive charge was concentrated in center. This explained why most of the alpha beam was passed through, and because the center of atom is so dense and positive, the alpha beam gets bent and deflected because both have positive charge. Also, this dense center was surrounded by negatively charged electrons that are stationary. He named this dense and positive particle proton. Some years later, working with James Chadwick, they discovered a new particle with neutral charge and named it neutron, and the proton and neutron at the center of atom was called nucleus. Fireworks were used in ceremonies and celebrations in China for more than 1,000 years. But have you ever wondered why they are so much colorful? Robert Bunsen, the inventor of famous Bunsen burner, noticed that whenever he put copper in a steadily burning fire, the color of the flames would change into green. He tried different elements and got different color. By passing the light of this different colored flame through a prism, instead of regular rainbow, he got only a few color stripes. In fact, each element has its own unique color compositions that is called spectrum. This phenomenon got the attention of Niels Bohr. He picked the spectrum for hydrogen. He knew that Rutherford's theory could not explain this spectrum of lights, so he came up with a new model for atom. In his model, he that refused electrons being stationary and not moving, and assumed that the electrons are orbiting around the nucleus on circles, similar to the planets of solar system that orbit the sun. At normal, the electron orbits on a smaller circle, the ground state. And when the electron gets energy, in form of light or heat, it jumps into orbiting on a bigger circle and goes into excited state. And when the electron jumps back to its original orbiting circle, it gives up the exact amount of energy that got earlier and goes back to its ground state. Hydrogen, for example, has one electron. Its single electron can get an exact quantity of energy and jump to higher orbits, and the more energy the electron gets, it can jump to higher orbits. And when it goes back, it releases the received energy in form of light or electromagnetic radiations, and bigger jumps release bigger energies when coming back. The important part was, the amount of energy received and released by electron always must be the same. This was the reason that hydrogen atom always made a spectrum of only 4 colors. Although Bohr's model was correct and did answer many questions, but it worked only for hydrogen. His model could not explain how the atoms with bigger electron numbers behave. This problem was later solved by Erwin Schrödinger, who came up with quantum model for atom. Because of its complexity, we will cover Schrödinger's model in our next video. In this video, all the topics were explained in a very simple way. The topic that require more explanation will be covered on separate videos. Make sure to hit the like button and subscribe to see our next videos. And feel free to leave a comment and help us make better videos next time. Logging out.